Will you look at an MCCB or its datasheet, you'll notice there is a lot of information, different voltages, different currents, different protection settings, and many technical parameters. That's why it's so important to categorize these values. By grouping them properly, we can understand the different types of voltages, the different types of currents, and how each one relates to a specific protection function inside the MCCB. So in this video, we'll break everything down into 3 clear categories on an MCCB: voltage features, current features, and protection settings current. This classification is based on the fact that MCCBs provide 3 main protection functions: short circuit protection, which includes both instantaneous and short time operation, and overload protection, which is the long time function. There are additional protection features related to ground fault and neutral conductor protection, but we are not covering those in this video. We'll leave them for a dedicated session later. As I said, we have a set of voltage features and current features that are fixed, constant numbers on the MCCB. These values don't change and they define the electrical limits on the device. Let's start with the easier group first. Voltage features: UE, UI, and Uimp. Let's start with the voltage related parameters. UE, operational voltage. This is voltage level that an MCCB is designed to operate under normal condition. For most LV breakers, this is typically 415 volt AC. UI, insulation voltage. This is the maximum voltage the insulation system inside the MCCB can withstand. It's always higher than UE, often around 690 volt. Uimp, impulse withstand voltage. This voltage tells you how well the MCCB can handle sudden voltage surge, such as lightning or switching spikes. A typical value is 6 kV or 8 kV. These 3 voltage parameters define the electrical environment the MCCB can safely operate in. You can find them in the datasheet as well. Next, we move to the current-related ratings or current features: IN, ICS, ICU, ICW, and ICM. IN is rated current. This is the continuous current rating of the MCCB. Depending on the trip unit, it may be fixed or adjustable. ICU, ultimate breaking capacity. ICU is the maximum short circuit current the breaker can interrupt once and still maintain structural integrity, but it may not be reusable afterward. Typical values are 25 to 36 kA. This rating must always be equal to or greater than the fault level at the installation point. ICS, service breaking capacity. If ICU tells you the maximum the breaker can interrupt once, ICS tells you how much it can interrupt repeatedly without losing performance. It's expressed as a percentage of ICU: 25, 50, 75, or 100%. A higher ICS means a more robust breaker. As you can see, it can be different number for different voltage level. Next, ICW, short time withstand current. This is the current that MCCB can withstand for a short duration, like 0.3 second or 1 second, without tripping or being damaged. It's essential for selective coordination. ICM, making capacity. This is a peak current the MCCB can handle if it closed onto a fault. ICM ensures the breaker can safely close even if a fault is present. These current features define how the MCCB behaves under fault conditions. Now let's look at the adjustable protection settings, the value you actually configure on the trip unit. II, short circuit instantaneous protection trip setting. This is the main parameter for short circuit instantaneous protection. When a current jumps to a very high level, technically 5 to 10 times of IN, the breaker trips almost immediately. ISD and TSD, short short-circuit short-time protection settings. Some advanced trip units include short-time pickup (ISD) and short-time delay (TSD). ISD defines the short-circuit level at which the breaker begins timing instead of tripping instantly. TS defines how long the breaker waits before tripping once ISD is exceeded. These two settings allow the MCCB to coordinate with downstream breakers and improve selectivity. Not all MCCBs include ISD and TSD, only those with higher-end electronic trip units. Short-circuit, short-time protection works hand-in-hand with ICW. Here's how. A fault occurs, the MCCB holds the fault current for a preset delay thanks to its ICW rating. If a downstream breaker clears the fault, the MCCB stays closed, no need to trip. If the fault persists, the MCCB trips after the delay. This prevents unnecessary upstream tripping and keeps the system selective. Finally, we have the long-time protection settings. IR, long-time pickup. This defines the overload threshold, usually adjustable between 0.4 times IN and 1 times IN, depending on the trip unit. TR, long-time delay. This determines how long the MCCB allows an overload before tripping. It prevents unwanted trips during temporary surge while still protecting cables from overheating. Together, IR and TR form the MCCB's overload protection system. A quick recap. To make all of these easier to understand, I've grouped the MCCB parameters into 3 simple categories. First, we have the voltage features. These are fixed values that define the electrical environment the breaker can safely operate in. Next, we have the current features. These tell us how the MCCB behaves under fault conditions, like braking capacity, withstand current, and making capacity. And finally, we have the protection settings. These are the adjustable parameters you configure on the trip unit, such as overload, short circuit, and instantaneous settings. Seeing them side by side like this help you understand not only what each parameter means, but also how they relate to the different protection functions inside the MCCB. I'm a master's level electrical engineer based in Dublin with over 10 years of experience in medium voltage system design and substation protection. And this is Exo Power Lab, where I break down electrical engineering, product comparisons, and practical insights. Thanks for watching, and I invite you to check out the other videos on the channel for more.